Hello everyone, thanks for the audience. I am Silva Moreno, postdoc researcher at PUC Parana, and I will do the talking about our research related to multi-step wind speed forecasting based on mid-stage decomposition approach. This research was doing with Ramon, Mateus, Viviana, and Leandro. Our agenda comprises 6 main topics, and at the end of this presentation, the Q&A session will be opened by the hosts. So, why wind power forecasting? Well, when the answer is quite simple. When we look at the Brazil numbers, it's quite impressive, the growth observed and compared with the rest of the world. So this brings new challenges to the operation and maintenance team due to wind power be highly sensitive to wind gusts, as we can see here. This pattern is quite complicated to do the operation and maintenance or do the forecasting to anticipate this scenario. The main contribution of our research is related to evaluating multi-stage signal decomposition approach for wind speed forecasting. Also, the use of different machine learning forecasting models combined of this multi-stage signal decomposition. The assessment of the proposed framework considering multi-step forecasting strategy from 10 up to 60 minutes ahead for wind speed time series. And the results was quite promising. Our approach considered two decomposition methods. The first one is variational mode decomposition, and the second singular spectrum analysis. So we can see here that we get good accuracy forecasting 10 up to 60 minutes ahead. The data set came from a real wind farm located at Parazinho, Rio Grande do Norte, and the overall installed capacity is 150 megawatts. And here we can see the pattern of the data set, which is related to March up to May 2020. And there's some gusts here or change of patterns here. So here we can see how difficult it is to predict this kind of signal. Our proposed method combine VMD and SSA as one multi-step decomposition approach as the pre-processing step of the signal. So the raw signal feed to the VMD algorithm, and we extract the trend component or some component that resembles the trend component, and the residual signal is decomposed by SSA, and from there we get 4 components, and then these 5 components it's applied to Q and N to do the forecasting, and at second model we choose the SVR or support vector regression to do the forecasting, and these 2 forecasting models will be compared analyzing the metrics related to mean absolute percent of error and root mean square error. So this is the result from the decomposition stage. The component C1 is related to VMD decomposition when we try to get the trend of the signal, and the remaining 4 components relate to SSE decomposition, when we can see high frequency signal and some noise here on this component. The results from the forecasting for each data set from 10 up to 60 minutes ahead is present here in table 1, and we can see that VMD SSEQNN has the better performance for all metrics considered and all horizons of forecasting related to March data set, and VMD SSASVR has the best performance ever for the 2 remaining data sets, April and May, also for all forecasting horizons. And here the combination of each one decomposition method and forecasting methods. So by analyzing this table, we can see that our proposed method outperforms all other kind of combinations of the SSA or VMD with which one of the forecasting methods. So when we look at the improved performance in our IP index, the best model was the VMD-SSA-SVR, and the worst one is related to QNN, applied as single model. Here we can compare the original signal and the forecasted signal obtained by VMD-SSA-SVR for each one of the data sets and for each one of horizons of forecasting. So it's quite impressive, the change of patterns here. Our proposed approach could follow this and predict as well, not the peak by itself, but the changing of behavior. It could be predicted with quite impressive quality. So the conclusion we relate to the accuracy and forecasting. Our approach outperformed all other single models, and for March, the VMD SSAQNN has the better performance than the other proposed approach, but when we look at April and May data sets, the VMD SSASVR has the better performance, and the improvement was quite impressive when compared to the others, approach. So here our research team, Ramon, Simvaldo, Mateus, Viviana, and Leandro, and we would like to thanks to the audience, and the Q&A session will be open at the end of this presentation by the host. Please don't forget to do your question about our research. Once again, thank you for your